Welcome everyone to the elimination method. This is part 3 of the systems of equations tutorial, the notes for advanced topics. Let's go ahead and get right into it. Two equations should be in the same form when you're using the elimination method. Okay, we talked about substitution, we talked about graphing. This is kind of like, I like this method the most just because it's really neat, it's organized, and it can be very quick sometimes. Now, sometimes it's not as good as substitution, but it's good to know. It's like another tool in your tool chest, and you use the strategies, determine the strategies of which when to use each. So preferably, you want these in standard form. Preferably standard form. That's when you have x and y on the same side of the equal sign with no fractions. So if we look in here at the blue and purple, both of these are in standard form. Okay. Now, step 1. Okay, equation should be in standard form. We want that. Okay. Determine if the x or y variables match or are opposites. Okay, so we want to know if they match or are opposites. Okay, now why is that? Well, you're going to find out soon, but it makes it very easy to solve when they match or are opposites. So we look at the y's, we see that the y's are not equal to each other. Their coefficients are 3 and 5. Those are not the same, and they're not opposites. We look at the x, and we see the coefficients for x are 2 and negative 2. Those are opposites, so we're in business with the x. So in this case, we're going to choose x to focus on. Okay, step 2, you don't always need, but it's important that step 2 goes here in case you do need it. Okay, in this first example, we don't need it, but we're going to multiply equations so that the x or y coefficients are opposites or matching. I'm going to put or matching in parentheses. I'm going to really emphasize the opposites method here today. Okay, I think it's sometimes we get so interested, teachers get so interested in teaching all the methods that they forget sometimes you just got to keep it simple. Don't give too much information, keep it simple. And so in my opinion, just roll with going with opposites. I think you're less likely to make a mistake this way. Any math teachers, go ahead and comment if you guys agree or disagree. But honestly, I've seen a lot of students make less mistakes when you only worry about finding opposite coefficients. Okay. So step 3, what do we do when we have opposite coefficients? Well, now we have to determine what strategy we're going to use. If we have opposite coefficients with your x or y, we're going to add the two equations together. Now, if they match, so if it was like 2x and 2x or 2y and 2y, we are going to subtract. You might see why I always want opposites. That way I'm always adding. So we are going to add or subtract the equations. That's not how you write subtract. Subtract the equations to eliminate variable and solve for the other. Okay, so we're either going to add or subtract to eliminate a variable and solve for the other. Okay, so let's go ahead and apply that here. I think we rewrote it. Yes, we did. Okay, so it's right here. Now, we recognize that they match. Okay, so these match. What we're going to do is we are going to add the two equations. What does that mean? Well, we're going to go row by row, and we're going to add each one of these lines. So here we're going to add, whoops, didn't want that one. Here we're going to add this column, we're going to add this column, and we're going to add this column. So 7 plus 1 we get as 8. Okay, we're adding all the like terms together. We get 3y plus 5y equals 8y. Now we have 2x plus a negative 2x. What do we get? We get 0x. What is this called? This is the whole point. This is why we're doing this. This is why we're choosing the variables we are, is because this is called elimination. What do we eliminate? We eliminated the x variable. We added opposites, so it eliminates, and then because we eliminate a variable, we're down to 1. It's much easier to solve. We have 8y equals 8. Divide by 8, divide by 8. We get y equals 1. So we solved for the other. When we say solve, it's x equals a number or y equals a number. It's not in terms of the other variable. It's not going to be like x equals 2y or y equals negative 2x plus 3 or something like that. Okay, so we have our first solution, and that's y equals 1. Once we get this, essentially we're doing the same process that we did with substitution. We're plugging back into the other equation. So we're plugging value of variable into any equation, doesn't matter, any equation and solve for the missing variable. So we're going to solve, so if you ever use multiplication, you could plug this into the multiplied. Change form, you could plug into the original. It doesn't matter. So what I'm going to do here is I'm just going to show, might as well use this one now, 2x plus, 5% left, 3, I'm going to leave a space here, equals 7. What did I do? Well, I left space for y because y equals 1. We determined that y equals 1, so now I can solve for x. Plus 3 equals 7, minus 3, 2x equals 4, divide by 2, I get x equals 2. Final answer. So now I have my ordered pair. My solution is 2, 1. Final answer. There I go. There's my x value 2, there's my y value 1. That's where the two lines intersect. Okay, now let's look at the next one, example 3. This is one where we're going to have to multiply. Guess what? The x's aren't the same and they're not opposites. The y's aren't the same and they're not opposites. So guess what we have to do? We have to change one of the equations. Pay attention closely. Now, what do we want here? Well, I want there to be opposites. I love it when there's opposites, okay, and I like adding. So that's what I'm going to do here. So where do I want opposites? Well, I want to multiply the least amount possible. If I want the x's to be the same, I'm going to have to multiply both of these equations to find the least common multiple, okay? What do 2 and 3 both go into? They both go into 6, so I'm going to have to multiply 2 by 3 and 3 times 2. That's no good. I mean, it's good, but it's not efficient. Instead, what I should see is, okay, look, my 3 can go into the 6. All I need to do is multiply the top equation by 2. I don't need to multiply both equations. So I'm going to rewrite this top equation after I multiply it by 2 to both sides. I keep the equation the same. It just looks different now. So I have 3y becomes 6y equals 24. Okay, so now what happened here? Well, I move this over. Guess what? They're the same now. But what I should have done instead, okay, what I should have done instead is not just multiply by 2, I should multiply by negative 2. Whoops. Why is that? Well, I want there to be opposites. So I should get negative 4x plus a negative or minus 6y equals a negative 24. This way, in my opinion, a lot of students do a lot better with this. They don't have so many mistakes when they're adding or subtracting a negative, blah, blah, blah. If they take care of it up front with the multiplication, they do a lot better. So now we have opposites. We are in business. So let's go ahead and get started on that. I have 4% left. Let's see how far I can get. So I have negative 4x. And then plus, now I'm just adding here. So I'm negative 4x plus x. I get negative x. This eliminates. That was the whole point. I don't even need to write anything. Okay, this just goes away. Equals negative 24 plus 21 is going to give me negative 3. Divide both sides by negative 1. And I get x equals positive 3. What do I do with this? I plug it into either equation. Doesn't matter. I can plug it into either 3. The green, the purple, the blue, who cares? So I'm going to plug it into the blue. So I get 2 times 3 plus 3y equals 12. So I get 6 plus 3y equals 12. Subtract 6, 3y equals 6. And then I divide by 3, y equals 2. I'm going to write it as an ordered pair, 3, 2, and there is my solution. This is where the two equations intersect. X equals 3 and y equals 2 solves, or is true for both equations. And I'm done. Okay, we have a lot of problems left. I'm going to try to do as many as I can before I get to like 2%. Let's see how far I can get. Okay, with this one, I'm looking here, and it's looking like I'm going to have to multiply both equations. No matter which way I do it, either 7 and 5, 2 and 3, I'm going to have to multiply both because both 7 and 5 go into 35. That's their least common multiple. 2 and 3, they both go into 6. That's their least common multiple. So we're out of luck. We need to multiply both. I'm going to multiply this top one by negative 3, and this bottom one by positive 2. And that way I get negative 6x minus 21y equals negative 12. Now, why did I choose the 3 and the 2? Just because I would have smaller numbers. I don't want to multiply by 5 and 7. I'd rather multiply by smaller numbers. So we get 6x minus, oh no, that's plus 10y equals negative 10. And I'm adding these two together. So that eliminates, that's the whole point. This gives me negative 11y, and then I add these and I get negative 22. So I divide by negative 11. Ooh, this is good. I get y equals positive 2. Once I'm done with that, I'm going to plug it into either one. I'm going to choose the purple one, the original purple one. I don't have to choose one of these. I can choose the purple if I want. So I'm going to do 3x plus 5 times 2 equals negative 5. 3x plus 10 equals negative 5. I get 3x minus 10. 3x equals negative 15. Divide by 3. X equals negative 5. Done. Okay. 2 more. This one I can see I'm going to multiply this by a negative 3 so I can make it the opposite. I'm going to write it right beneath here. So I get negative 6x plus 3y equals negative 9. Okay, I'm adding these two together. Get rid of that thing. Okay, I eliminate. Okay, I get 0 equals 0. What does that mean? If you get 0 equals 0, that means that's true. That's a true statement. This is all real solutions. Okay, this is infinite solutions. I like that better. So this is infinite solutions. Okay, they're the same line. Same line. Okay, they are a dependent system. That's one way to see it. Okay, so let's go ahead and move it to the last one. If you want to pause and recheck that one, that's fine. But I'm moving on because I'm running out of juice. So I multiply this one by 2. Why do I multiply it by 2? Because this is negative 2x, and I have a positive x here. It's very easy to get the top one matching up. You could have done the same thing with the y, but I just saw the x and decided to roll with it. So I'm going to write this underneath here, just so you can see it. So I have 2x plus 6y equals 8. So let's go ahead and add these two. I eliminate that. Okay, so that's 0 on the left side, and then I get 11 on the right. Okay, this is not the same case. We don't have 0 equals 0. Is that a true statement? Is 0 equal to 11? No. This is no solution, okay, because they are, inconsistent systems. Inconsistent system. They don't intersect. They are parallel line, and so there's no solution. Hopefully this is helpful, and you guys get to see how useful the elimination method is. Hope you liked it. Thank you so much for watching. See you next time. Isn't that nice?